Hello to you all! In today's lesson we're going to be answering the question, what are the different types of energy resource and how do they work? Welcome to What's Your Question? Let's go! Just linking to that then, I've got 3 questions for you to start off with. You can pause the video after we've been through what the questions are and have a go at answering them, and I'll go through the answers for you. The 3 questions you need to answer are what's a renewable resource, what's a non-renewable resource, and what are the 3 fossil fuels. Pause the video here, 3 types of fossil fuels. Pause the video here, have a go at writing the answers to those questions down. Great, so a renewable resource then is a generally natural resource that if we use it, we're not going to deplete the amount of that thing. We'll talk more about examples of this a bit later on in the video. A non-renewable resource then is if we start using that resource, we're going to deplete the total amount of that is available to us in, say, with the Earth's crust if we're finding it there, or wherever it's being found. So if we're using it, we're reducing the amount of it that there is. And finally then, the 3 fossil fuels you need to be able to name are coal, oil, and natural gas. If you have any questions about that, throw them in the comments. We can go through the answers together. I might make another video if you make any good points or good questions. Your objectives in today's lesson are that you're going to describe the main energy resources available for us to use on Earth. You'll be able to distinguish between the different ones that are renewable and the ones that are non-renewable, and you're going to explain how we use each one. Basically, you're going to explain how they work. Okay, so to start with, then we need to go through what the different types of energy resource are. There are 9 you need to be able to name. I recommend you pause the video here and you have a go at writing them out in the comments or on some paper before I tell you what they are, just to see if you know before I tell you. Pause it here. Okay, so the 9 different types of energy resource you need to know of are fossil fuels, things like coal, oil, and natural gas. We have nuclear fuel. Generally we use uranium as our nuclear fuel, and this is what produces our electricity. We'll go in more detail later in the video about exactly how they go about making the electricity, but for now you need to know what they are really. We have biofuels, which are leftover plant material that we burn to produce our electricity. We have wind, which is fairly self-explanatory. We have hydroelectricity, which uses water to produce the electricity. We have geothermal, which uses hot rocks underground to produce the electricity. We have tidal, which uses the tides, so when the sea comes in towards the beach, we use the tides to produce electricity. We have solar, which uses the sun, and we have wave power, which uses waves to produce the electricity. Some of these are renewable and others are non-renewable. We've talked about what these are already earlier in the lesson. You should pause the video here and see if you can sort those into the 2 categories. Which ones are renewable, so which ones aren't going to run out if we use them, they're not going to deplete over time, and which ones are we going to use up over time. There are 2 non-renewable ones, and the rest of them, the other 7 then, are renewable. You should please try and work out which ones are not renewable. The non-renewable ones then are fossil fuels. We have to dig underground to find these. They take millions of years to make. Once we use them all up, there will be no more. Petrol fits into this one. Most of the fuels we use for most of the stuff that we use will also fit into this category. So it's the reason why we're trying to find other methods of producing our electricity at the minute. The other one of these is nuclear, because although the fuel that we use will last a long time, it is renewable, is non-renewable. We are going to run out of it because uranium is only very finite on this planet, so we only have a certain amount of it that we'll be able to find. The other 7 then, the biofuel, wind, hydroelectric, geothermal, tidal, sun, and wave power are all examples of renewable energy sources. So no matter how long we use those for, we won't be depleting the amount that we have. They're going to be available for all that time. Making electricity using these sources is fairly simple. For most of these, it involves the Fleming's left-hand rule ideas that you will have come across before, and that's that if you have motion and you have got a magnetic field, you can produce a current. The Fleming's left-hand rule just tells you how motion, force, and currents relate to each other in terms of the directions they'll happen in, but as long as you have 2 of those things, you can produce the 3rd. So if we have got something moving in a magnetic field, we should be able to produce a current, and that's exactly what we need to do in most of these cases of producing electricity. The simplest one of these to explain is fossil fuels. So I'll start off by explaining how that one works. A lot of these start off very simply with a turbine. This turbine is like a big fan, and that turbine is attached to a magnet, and the magnet is inside a coil of wire. Okay, the magnet is going to spin, the coil of wire is going to spin, and the magnet will be inside the coil of wire. That way we have movement, we have force, and we have a magnetic field, and that means we should produce a current inside the wire. All we have to work out is how to spin the turbine. When it comes to fossil fuels, we burn the fossil fuels to heat up water, the water turns to steam and spins a turbine. As long as the turbine spins, electricity will be produced. There's a fly. When it comes to nuclear fuels, we're using a radioactive material, uranium, I think plutonium sometimes can be used as well, uranium, and those radioactive sources are giving off energy because they're radioactive, and the energy they're giving off is funneled into water, and that water then evaporates in the same way. So it works in pretty much the same way as fossil fuels, it's just more dangerous because that uranium is highly radioactive, and so we need to be concerned about it because lots of energy is given off, and then we can have huge negative effects like what happened in Chernobyl, where we had a large explosion and lots of radiation pumped out because the conditions were not kept correct within the reactor. For biofuels, again, we're still turning a turbine, we're just burning biofuels to spin that turbine instead of what we normally do. For wind power, this is fairly self-explanatory, as wind power literally involves you having massive fans, massive turbines out in the countryside that take up lots of room, can affect habitats, and all they do is get spun by the wind to produce the electricity. We have hydroelectric power, which generally is they use a large dam. They'll have the water high up on one side and the water low down on the other side of the dam, and there'll be a tube inside that dam the water travels through, and there'll be turbines within that tube that as the water travels downhill towards the lower water, it spins turbines to produce the electricity. We have geothermal power. Again, we're using steam in this one. We pump water down into the ground to where the rocks are very, very hot. This will allow the hot rocks to boil the water and turn the water to steam. The hot steam then rises back up the pipe on the other side, and there'll be a turbine at the top, exactly the same as before, attached to a magnet inside a coil of wire that produces our electricity. Tidal power uses the tide coming in to produce that electricity, just like any other of these. There'll be a turbine inside to do this, then we connect to something to produce electricity, and waves are using the waves to do this. The only one of these that's different is solar power. In solar power, there are two layers of silicon. One will be positively charged and one negatively charged, so one's got too many electrons, one's not got enough electrons. As the sun hits the solar panels, it excites the one with too many electrons, causing the electrons to be given off and start a circuit, start a current flowing. The end of that circuit will be on the positive side, where the electrons will be gained by the silicon on that side as well. This means we have a complete circuit going around, and our current is then able to flow. The more sunlight, the more electrons are excited, so the more current and the more electricity you will produce. So solar power is one other way of us producing that electricity. Thanks very much for watching. Make sure you stay safe, stay alert, stay curious, and subscribe.